Hey there everyone, welcome to our new series connecting Ansys to SQL the Ironpython way. Now the main reason I am creating this video series is that we need to understand what is the use of this SQL and how we can connect it with Ansys. Now the question arises, why does a person or the engineer who is using Ansys require SQL? And then we will understand, once we have why this is required, then we will try to understand that how do we connect Ansys with SQL. As you know, Ansys has inbuilt Python, and we have no way to install any Python modules, and so that makes us difficult. So here we will try to understand how we can connect Ansys with SQL without having to install any external modules. So let's begin with the requirements first. So let me just make it clear that why do we need any SQL server or any relational database management system. So let's say you have a model. So first thing is you have a geometry. Now in geometry, let me keep it very simple. Let's assume that we have a cylinder. Cylinder will have certain dimension. So let's say you have L and you have diameter D. It may be a cube. Let's keep it very simple just to make it clear. And then this is a cube and it has three dimension A, B and this C. So this geometry will have certain material. So this is material. Let's make it mat A. It will have certain density. It will have certain Young's modulus. It will have certain Poisson's ratio. And then you will do certain mesh. So it will have mesh. It will have certain size. It can be anything. Let's keep it mesh setting. And then once this is done, you will have certain result. If you are doing model analysis, you will have certain critical frequencies, maybe in frequencies like f1, f2, so and so. Or if it is a static analysis, you will have certain deformation. Let's keep it D for deformation. And or you can have some stress. So it can be anything, von Mises, max, principal, whatever it is. So here we found out that it has certain input and output. For example, it has a geometry, which is our input. It has material, which is also an input. You have mesh as an input. You also have a result as an output. Let's say the person who is doing the analysis, since we are all talking about automation, so it has some user. You will have certain user. So you did the analysis, then after 2 or 3 months you got the same analysis again, and let's say this analysis took almost one night, one day. It can be anything. So it doesn't mean that you have to do the analysis once again. So you can have a backup. You can have a server where you have all the data stored. So for example, you will have all input. uh, we make it input and output, backup, and what else for audit purpose. So who has done the analysis? For example, this user who has done the analysis. After few months or years, suppose you are having an analysis requirement telling that this model needs an analysis, so you will just go to the database and search that whether this was done previously or not. Or maybe the same model has a requirement for different material. You want to do some analysis, like who is having the minimum deformation, which material is having the maximum deformation. All this can be stored in this server. So this is one of the primary requirement. Or let's say you have a geometry model, and in future you want to do some analysis, or you have lost the all the geometry details, what analysis was done. So you can easily go to this server and check that for so and so requirement this was the model used. So this is one way. Then another way is, let's say, uh, one more requirement is, let's say you are doing an automation tool. You are creating a GUI for this, where it has some list box, some buttons, and it has a drop down. Okay, it has a drop down, and drop down has certain list. For example, here yeah, you are importing a model here in this automation GUI, and then it has a drop down for material. Okay, in that material you have mat A, you have mat B, which is already fed into this automation tool. Let's say after 1 week, the client comes or the requirement comes that you have to add mat C also. So what you will do, you will take the automation script, you will add a new material and send it across your users, telling that there is a slight change in the code, maybe a minor version is added up, and you will add this material C. Then again after 1 week, they come with telling that Mat A has some new grade now, maybe 60, this was 50. So they add this material A in that list. So they want to do this automation. So again after 1 or 2 weeks, you will add some new minor version to it. But do you think this is the right way? This is not the right way to create an automation tool. What if I will add all this into a SQL server? Whenever this GUI is called up, whenever the automation software button is clicked, the moment it pops up, it will first do a query and it will see what are the new materials added up. So what you will do in SQL server, you will create a table in which there will be material column, and then you will add all this material A, B, C, A 60, this one was 50, 1, 2, 3, 4, and whenever this added up, this list gets populated automatically. So the main requirement is to have a dynamic config tables. So I will add it as config, and then in future if you want to do analysis or anything, so you can do everything through this SQL server. So how are we going to do this? As you know, Ansys has default Ironpython 2.7, Ironpython 2.7, and it has .NET framework inbuilt, which is 4.0. Now, in Ironpython, there is a default module known as CLR module. CLR is nothing but Common Language Runtime. So we will not go deep into this, but what we will see is CLR module is inbuilt present in Ironpython 2.7. So this CLR is actually a virtual machine component of the .NET framework, which executes this .NET framework. So what happens is you are writing a code in Python, so especially it's Ironpython, then it calls up as CLR, then CLR executes or converts this compiled language into some native language, which is our system default language. So CLR is already present. With this CLR, we will try to connect with various SQL server. In this series, we will see some of the SQL server. For example, this is Microsoft SQL Server. We will also see MySQL. We will also see postgreSQL, and we will also see SQLite. And if time permits, we will also see Oracle database. So this was the main motto of this video series. Without installing module, we will try to connect Ansys with various servers: SQL Server, MySQL, PostgreSQL, SQLite, Oracle, and we will exchange data. So we will send a query to get some data. We will also use update query to update our SQL database. For example, in this in here, after we do the analysis, we will input the materials and geometry and the mesh setting and also the result into the SQL server. We will do some audit, we will do the analysis, and we will see what was the result when this was the material. You can do some iterations over this data itself without doing the analysis, and we will also insert some config table. So in the next video, we will see how we are going to do the data modeling, like how we are going to create tables, and then in subsequent videos we will connect to all the SQL servers through Ironpython. So this is not just specific to Ansys, this is the Ironpython way. For example, anyone who uses Ironpython or the Python which has the CLR module can use this method to connect to SQL server. That's all for this video, guys. See you soon in next video.